Welcome my dear students, first secondary Rajak Language School. We will meet with Unit 4, second term, heat content, basic concept of thermochemistry. All the chemical changes and the physical changes are accompanied with changes in energy. Physical change, it means that change in the shape of the substance or matter without any shape in the structure, such as melting, evaporation, condensation, and so on. While chemical change or chemical reaction mean the change in the shape and the structure of the substance or matter, leading to new substance with new properties such as rusting of iron, burning process, and so on. All physical and chemical changes are accompanied with what? Changes in energy. Energy is very important for all living organisms to do our activities. Without energy, we can't move. The other various activities, whether they are mental or muscular activities, can't be achieved or carried out without the need for the produced energy from burning sugars inside our body. What is energy? From primary and the prep stages, energy is ability to do work or to make a change. We would also not be able to cook our food without heat energy resulting from the burning of the natural gas. Science that deals with the study of energy and how energy transfers is called thermodynamics. Thermodynamics, the science that deals with energy and how energy transfers. Another branch of thermodynamics, scientists became interested in studying a branch of the thermodynamic concerned with the heat effects or heat changes that accompanying the chemical reactions or chemical changes and the physical change. Again, science that is concerned with or interested in studying heat changes accompanying the physical changes and the chemical changes or chemical reactions is called thermochemistry. Thermochemistry is a branch of what? Of thermodynamics. Law of conservation of energy. There are various forms or different forms of energy like chemical energy, heat energy, light energy, electrical energy, and kinetic energy, and so on. However, through the classification of energy into different forms, you can imagine that each form is independent form in itself. While in spite of this, there is a relationship between all forms of energy as energy is converted or transferred or changed from one form to another one. This leads to the statement of law of conservation of energy. Energy is in any physical or chemical change can be neither created nor destroyed, but it can be converted or changed or transferred from one form to another one. But what is the relationship between chemical reaction and energy? We will identify here other two concepts, system and surrounding. Most chemical reactions are accompanied with changes in heat energy, as most chemical reaction may release energy or absorb amount of energy. Energy exchanges occurs between or takes place between the reaction mixture and the surrounding. The reaction mixture is called system, and the parts of the universe outside this system with which the system interacts called the surrounding. So system here is the part of the universe in which a physical or chemical change takes place, or it is a part of the substance chosen for study. While surrounding is the part outside the system and exchanges energy with the surrounding in the form of heat or work or both of them. Here, if we have a test tube, inside it a reaction occurs. This test tube that has reactants and the products, the reactants and the products, or the reaction medium here is the system. The boundary of the system is the wall of the container or the flask or the test tube. Outside, the part outside the flask or container or the test tube is called the surrounding means lab or the class. So in case of chemical reactions, as we said now, the system expresses the reactants and the products. The system boundary may be container, flask, or test tube in which the reaction occurs, while surrounding may be anything outside this reaction. Types of systems according to ability of the system to what? To exchange energy or matter with its surrounding system may be classified into three types: isolated system, open system, and closed system. Isolated system, it is the system doesn't exchange either energy or matter with its surrounding. So in this case, the system doesn't interact with its surrounding. Open system, such as a cup of tea, it freely exchanges matter and energy with its surrounding. Closed system, such as medical thermometer, it exchanges only energy in the form of heat with its surrounding, but not matter. It exchanges energy but not matter with its surrounding in the form of heat. First law of thermodynamics: any change in the system energy is accompanied by a similar change or the same change in the surrounding energy, but with opposite sign, so that the total energy remains constant. Why opposite sign? Because here system and surrounding, one of them loses energy and the other gains the same amount of energy. Lose means negative, gains means increasing or positive. So delta means a change. Delta E system means a change in energy of the system equals in negative delta E surrounding. First law of thermodynamics is concerned only with isolated system. This first law of thermodynamics: total energy of an isolated system is constant value even if the system is changed from one state to another one. After that, my dear students, first secondary, we will identify heat and temperature and the difference between the two concepts. Heat, flow of heat from one position to another position depends on the difference in temperature between two positions. So what is meant by temperature, and what is the relationship between the temperature and the kinetic energy of molecule? Before we enter temperature, again, heat is a form of energy. Heat, a form of energy, transfers from higher position in temperature to lower position in temperature. Means the flow of heat from position to another, from object to another, between two bodies depends on the difference in temperature, and the heat will stop its transferring when the two positions or two objects or two bodies equals in temperature. While temperature is a measurement of the average kinetic energy of the molecule of matter, and it indicates the hotness and coldness of an object. Measurement of average kinetic energy of molecules of the matter or substance, and indicates hotness or coldness of the object. Molecules and the atoms of the substance, as we previously studied in first prep stage, are in a continuous motion or vibration. However, these molecules differ in their speed in the same substance. The system is formed from a group of molecules that react with each other, where when the average kinetic energy of the molecules increases, this means temperature also increases. Heat, a form of energy, it is considered as energy transferred between two bodies or objects of different temperature. Whenever the system absorbs heat energy, the average speed, why we don't use the speed and use the concept average speed? Because here the speed of the molecules of the same substance is different from each other. Average speed of molecules when increases, this means that kinetic energy of the molecules increases, leads to the rise of the system temperature and vice versa. So there is a direct relation between the system energy and kinetic energy of its molecules. Measuring units of the quantity of heat. Here, measuring unit of the quantity of heat by calorie and joule. Calorie, quantity or amount of heat needed or required to raise the temperature of 1 gram of water by only 1 degree Celsius. For example, from 15 to 16, don't forget 1 kilogram equal 1000 gram. Similarly, 1 kilocalorie equals 1000 calorie. Joule is less than calorie. Amount or quantity of heat needed to raise the temperature of 1 gram of water by 1 divided 4.18 degree Celsius. So when we convert calorie to joule, 1 calorie equals 4.18 joule. When we convert from calorie to joule, multiply by 4.18. When we convert from joule to calorie, divide by 4.18. After that, we will identify specific heat. Here we will stop in this video and we will continue to complete the lesson again, inshallah. See you later.